So now let's solve the original problem that we originally wanted to address. We want to know if the two machines produce bearings that have different diameters. Because of our f-test, we assume that the standard deviations of these two machines are equal to each other. Okay? So we go back over here and we want to address this set of hypotheses, assuming that the two variances are equal to each other. Sigma 1, sigma 2 are unknown. We're using S's, sample standard deviations, in place of those sigmas, but we're going to assume that they're equal to each other. Okay? So we have degrees of freedom here, N1 plus N2 minus 2. Okay? That's 27 plus 32 minus 2, which is 57. Okay? And we've got a test statistic here. That is y1 bar minus y2 bar minus this difference that we want to test for, okay, mu1 minus mu2, over the pooled variance calculation. Okay? That is n1 minus 1 times s1 squared plus n2 minus 1 times s2 squared divided by n1 plus n2 minus 2. We're going to multiply that by 1 over n1, a square root of 1 over n1 plus 1 over n2. Okay? So we've got all this. We just got to plug it in and do some arithmetic. Okay? So we've got y1 bar, 8.73, minus y2 bar, 8.68. We're going to calculate that sample evidence, how different that sample evidence is from 0, the hypothesized difference we want to determine, over n1 minus 1, that's 27 minus 1, times s1 squared, 0.35 squared, plus n2 minus 1, 32 minus 1, times s2 squared, 0.4 squared. All of that over n1 plus n2 minus 2. Then we've got to multiply that by the square root of 1 over 27 plus 1 over 32. Okay? So this is our test statistic. We can work this out, just arithmetic, and that's equal to 0.506. 0.506. So we have a test statistic, T naught, of 0.506. So let's go over here where we've got some room, okay? And we have a T distribution with 57 degrees of freedom. And let's say we wanted to calculate a p-value associated with 0.506, okay? This is a two-tailed test. So the area that we calculate right here, we got to multiply that by 2 to get the p-value. Okay? We're not going to find exactly 57 degrees of freedom in our t-tables, so we need to use Excel. Okay? So here the p-value is going to be exactly the t-dist function in Excel. If we put in the value on the axis, 0.506, we put in the degrees of freedom, 57, and we choose a two-tail probability. Two-tail probability. Okay? If we choose the two-tail probability, it takes that area and multiplies it by 2. Gives us the p-value exactly. If we do that, we get a p-value of 0.615. Okay? So the p-value here, 0.615. Okay? That's huge. That's much bigger than any alpha that you'd ever choose. Okay? Alpha of 0.05, alpha of 0.1. P-value, much bigger. Okay? When the p-value is bigger than alpha, we do not reject the null, and we conclude that the means are the same. Okay, so the mean diameter of the bearing produced by machine 1 is equal to that of machine 2. And so we have no reason to believe that those machines are producing a mean diameter that's any different from each other.